So this chapter is very similar to the previous chapter, that is continuity and differentiability. So before seeing this video, I would like all of you to go through the previous video so that you get thorough in all the formulas of differentiation, so that this chapter will be very easy for you. So in this chapter, coming back to this chapter, so I have provided you all with all the important concepts. All the concepts I have provided, because all these things are very important and it is a very important weightage also. You have been provided with 10 marks in AOD, so it is a very important chapter. So I have provided you with all the necessary information, all the necessary concepts, and some very important questions that are related for the exam point of view. So I would like all of you to go through the previous video again, get thorough with all the concepts of differentiation. And if you want me to help you out, I am ready to help you out. You can book for a special class with me. I have given you my WhatsApp number in the description box, so you can contact me at any time and book for a class, and I would be very glad to help you guys out. So looking forward to many such classes in the future, and many interesting videos will be coming out in the future as well. So now let us go into the session. Let's rock and roll collectively. Thank you. So in this session, we are going to see applications of derivatives. Yesterday we saw continuity and differentiability. So in today's chapter is very much of a resemblance to the previous chapter. So before we go to this chapter, I would like all of you to revise yesterday's chapter. It is available in the YouTube. I have already given the link, so you can refer to that chapter for all the differentiation formulas, and then after going through it in a glance and practicing some of the questions, then you can approach this chapter. This is a very simple chapter. This is just the applications of derivatives, as the name itself suggests. So here you have some of the important topics like rate of change of quantities, increasing and decreasing functions, and also maxima and minima. So rate of change of quantities is very simple topic. So it's just denoted by the symbol dy by dx. As you all know already, dy by dx means rate of change of y with respect to x. Especially for the first exercise, you have to remember some very basic elementary formulas like area of the circle, area of the rectangle, volume of the cylinder, volume of the sphere, and all those things. So I have given all those data here. Area of a circle is pi r square, circumference of a circle is 2 pi r, volume of a sphere, Vs means volume of a sphere, so that is 4 by 3 pi r cube. Area of a rectangle is length into breadth. Perimeter of a rectangle is 2 times length plus breadth, that is 2 into L plus B. And volume of a cylinder is pi r square h. Volume of a cone is 1 by 3 pi r square h. Area of a cylinder is 2 pi r h. Suppose, for example, the questions may be asked like find the rate of change of area of a circle with respect to its radius. Like that, the questions will be asked. So rate of change of area of a circle with respect to its radius means you have to find dA by dr. dA by dr, they will be already giving you the value of radius. So you have to differentiate this. When you differentiate this with respect to r, you get 2 pi r, and then you have to substitute the value of radius, which would have been already given in your question. So like that, they will be asking you. So these elementary formulas you should know. So that is why I have given all this data. And then comes the next topic, increasing and decreasing functions. So increasing and decreasing functions, the topic is very simple. So for a given function f of x, there will be a question given. You have to differentiate that function. Differentiation, as I told you, it is this chapter is repetition of the previous chapter. It is very similar to the previous chapter. So go through all the differentiation formulas. So if you go through all the differentiation formulas and if you are thorough with how to differentiate a given function, then these things will be very easy for you. So you have to differentiate a function and find f dash of x, and after that, if f dash of x is greater than or equal to 0 strictly in that given interval, then you can call it as an increasing function. Or if f dash of x is strictly less than 0, I mean less than or equal to 0, you can call it as a decreasing function in that given interval. Suppose if f dash of x equal to 0, then that means it is a constant function. Suppose if the interval is not given, and if you have found out that f dash of x is strictly greater than 0 irrespective of the value of x, then it is a strictly increasing function. If f dash of x is less than 0 irrespective of the interval, suppose for example f of x equal to e power x, let us take a function like this. f of x equal to e power x. When you differentiate f of x, you get again e power x. E power x for any value of x, it is going to be an increasing function because the value is anyway going to be positive. So that is strictly increasing function. Suppose if you take the value f of x equal to minus x, I'm just giving you an example. So if we differentiate the function, we get minus 1. Minus 1 is anyway less than 0. So it is going to be compulsorily decreasing function. So this is strictly increasing, strictly decreasing. And if f dash of x equal to 0, then that means it is a constant function. Take for example a constant value, f of x equal to 3 or 4, something like that. So if you differentiate a constant, you are anyways going to be getting 0. So that means it is a constant function. So this is about the topic of increasing and decreasing functions. Next we go to maxima and minima. Here you have two types. One is local maxima, local minima. I have given you the steps. So for a function f of x, you need to find f dash of x and equate it to 0, and you will be getting some x values. Sometimes you will be getting only one value, sometimes 2 or more than 2, 3, something like that. So those values of x are called critical points or stationary points. Critical points I have indicated as CPs. Now you will have to double differentiate the function. That means you will have to twice differentiate f of x. For example, f of x is given as 3x square. For example, I am telling 3x square's normal differentiation f dash x is 6x, and double differentiation of 6x will give you 6. So like that you will have to do. So find the f double dash of x and substitute the critical points to find f double dash of CP. And if you have found out that f double dash of CP is less than 0, that means it has got a local maxima. That is a conclusion that has got the local maxima, and the maximum value is f of CP. Again, you will have to go to your question and substitute this value to find the maximum value. Suppose if f double dash of CP is greater than 0, then that means it is a local minima, and for finding the minimum value, you again have to go back to your question and substitute f of CP. So this is the procedure for finding local maxima and local minima. This is a very, very important topic. You just have to follow these steps. If you remember these steps and if you apply it in the correct way, you will be able to find out the answer quite easily. Okay, now we go to another classification of maxima and minima, which is called absolute maxima and absolute minima, which is relatively very simple topic than compared to this. Okay, absolute maxima and absolute minima, there will be an interval. See, the difference between local maxima and local minima and absolute maxima and absolute minima is, in local maxima and local minima, there would be an interval given. If there is no interval, and if they are simply asking you to find the maximum value and the minimum value, then that means it is a local maximum and local minimum. Suppose if they are asking you to find the if they are asking you to find the maximum and minimum value, when they have provided you the interval, then that is called absolute maxima and absolute minima. So that is how you have to differentiate between absolute maxima and absolute minima and local maxima and local minima. So now there will be a given interval f of x. There will be a given interval f of x in a comma b, closed interval. So you have to differentiate it and equate it to 0. The first step is very similar to the local maxima. So you have to differentiate and equate it to 0 to find the critical points. And you will have to find all the values of f of a, f of b and f of CPs. The maximum of that value will be giving you the absolute maxima, and the minimum of that value will be your absolute minima. So this is a simple procedure. There is no complication like double differentiate and all those tricks are not required here. Just differentiate f dash x, equate it to 0, find CP, and then find out the values of f of a, f of b and f of CPs. The maximum value gives you the absolute maximum, minimum value gives you the absolute minimum. So these are the steps. So with this, your concepts, all the concepts of AOD is over. Now we go to some of the important numericals. Here you can see I have given you, before the first exercise, you have to go through examples 2, 4 and 6 related to the first exercise. Now in exercise 6.1, I have given you some 9 sums from 1, 2, 3, 4, and after that 6, 9, 10, 13, 16. All these questions you will have to go through, and the next examples are related to the second exercise, that is increasing and decreasing functions. So example 8, 9, 11 and 13. And then comes the second exercise. In the second exercise, you will have to go through 3, 5. Under 6, you will have two subdivisions. And after that, 9, 10, 14 and 16. And before the final exercise, local maxima and local minima, you will have to go through these sums. 29, 30, 32, and 39. And in the exercise 6.5, I have given you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Subdivisions I have taken as one common question. So I have given you 13 sums overall. So with this, your AOD chapter is over. I think that I always insist you again and again to go through your previous chapter notes, to go through the previous video, so that when you actually study this chapter, if you had revised your previous chapter, this chapter would be very useful for you. I think it was a very useful session. So we'll meet with many interesting sessions in the future. Thank you and all the very best to you guys.
Together we'll fall apart.